Good day, everyone. Welcome to I² Maths Academy, where numbers and variables actually meet mastery. In our last class on integration, we actually looked at integration of this form, integral the x all over a plus b sine square x plus c cos squared x. Yes, we actually looked at integrals of this form. Now we're going to solve another example using this substitution. Yes, remember we said when you have an integral, yes, an integral in this form, yes, all you need to do is to substitute. Yes, is to substitute t is equal to tan x. Yes, that's just the principle guiding this kind of integration. Now let's look at example 2. Now, example 2. Yes. Now, solve integral the x all over 4 sine square x plus 5 cos square x. Yes. The x all over 4 sine square x plus 5 cos square x. Now, in this case, now remember we said the first step is to substitute this. Yes. So let t be equal to tan x. Yes, let t be equal to tan x. And if t is equal to tan x, it means the t all over the x will be equal to sec squared x. Yes, remember our class on differentiation. We said when you differentiate tan x, it gives sec squared x. So here, the t all over the x is sec squared x. Yes, so the t all over the x is equal to 1 plus tan squared x. Yes, sec squared x is the same thing as 1 plus tan squared x. Yes, now let's look at this. Now we said sine squared x plus cos squared x is equal to 1. Now let's divide through. Let's divide through by cos squared x. So here we have sine squared x all over cos squared x plus cos squared x all over cos squared x is equal to 1 all over cos squared x. Now remember we said tan x from trigonometry, tan x is sine x all over cos x. Yes, so it means the whole of this now, sine squared x all over cos squared x is tan squared x. Then here we have plus cos squared x divided by cos squared x is 1. And we know that 1 all over sine x is cosec x. 1 all over tan x is cotangent, that's cot x. And 1 all over cos x is secant, that's sec x. So it means this 1 all over cos squared x is sec squared x. So it therefore means that sec squared x is the same as 1 plus tan squared x. And that's exactly what we're using here. Yes, we said the t all over the x is sec squared x. Now, the t all over the x is the same as 1 plus tan squared x. So now, the t all over the x will be equal to 1 plus. Now, remember the value of our t, here we said let t be equal to tan x. So, if t is equal to tan x, it therefore implies that here, tan squared x will be t squared. Yes, it will be t squared. Now, let's look at this. The t all over the x. Yes, the t all over the x will be equal to, we have 1 plus t squared. So the t, when you cross multiply, it gives 1 plus t squared. Then here we have the x. Yes, 1 plus t squared the x. Now, making the x the subject, so here we have the x will be equal to the t all over 1 plus t squared. So that's our the x. Now let's take note of this now. Let's take note of this. Yes, the x is the t all over 1 plus t squared. Now let's look at this function again. Now, if t is equal to tan x, if t is equal to tan x, now let's bring out our right angle triangle. Yes, now the angle here is x. The angle is x. And remember the definition of tan. Yes, we all know that tan can be defined, or tangent can be defined as the opposite all over adjacent of a right angle triangle. I take it again. The tangent of an angle can be defined as the opposite side all over the adjacent side of a right angle triangle. So it therefore means that here, yes, we are looking at opposite, and we all know that the side facing the given angle is the opposite. So here we have T. Yes, we have T. Then the adjacent is 1, because this is the same thing as saying if T is tan x, it means tan x is the same as saying T all over 1. Yes, because T all over 1 is the same thing as T. Yes, so we have opposites all over adjacent. Now let's call this side Z. Let's call this side Z. So now from Pythagoras theorem, we know that the hypotenuse square is equal to the sum of the square of the adjacent and the square of the opposite. So it therefore means that here, Z square is equal to 1 square plus T square. So here our Z square will be equal to 1 square is 1 times 1. Then here we have plus T square. So it means that the value of our Z, yes, the value of Z will be equal to the square root of 1 plus T square. That's Z. So it means the side is the square root of 1 plus T square. Yes, that's the value of Z. That's the value of Z. Now, since we have this, now let's look at the value of cos x. Now, cos x. Now, remember the definition of cos. Yes. Car. Yes. That is adjacent all over hypotenuse. So the cosine of an angle can be defined as the adjacent side all over the hypotenuse side, or divided by the hypotenuse side of a right angle triangle. So it means here cos x now will be equal to, yes, cos x now will be adjacent all over hypotenuse. So we have adjacent 1, the hypotenuse is 1 plus T squared. Yes, that's cos x. So if cos x is equal to this, it means cos square x will be 1 all over the square root of 1 plus T squared all squared. So it means cos square x will be equal to, if you square, 1 square is 1 all over 1 plus T squared, the square root square. It will give us 1 plus T squared. So that's the value of our cos square x. Now let's figure out the value of sine x. Let's figure out the value of sine x. Yes, but before we look at sine x, let's figure out the value of 5 cos square x. Now 5 cos square x will be equal to 5 times cos square x. And cos square x is 1 all over 1 plus T squared. It means the whole of this now will give us 5 all over 1 plus T squared. Yes, so that's the value of 5 cos square x. Now let's bring out the value of sine x. Yes, sine x. Yes, now we all know that sine can be defined as the opposite side all over the hypotenuse side, or divided by the hypotenuse side of a right angle triangle. So here we have opposites, the side facing the given angle, and the side facing our angle 90 degrees, that's the right angle, is the hypotenuse. So we have T all over the square root of 1 plus T squared. Yes, that's the value of sine x. Now let's see the value of sine square x. Yes, let's see the value of sine square x. Now let's see the value of sine square x. So if sine x is equal to this, it means sine squared x will be equal to, we have T all over the square root of 1 plus T squared all squared. And that will give us T squared all over 1 plus T squared. Yes, that's the value of sine square x. Now what we have here is 4 sine square x. So let's see 4 sine square x. So 4 sine square x will be 4 in brackets. We have T squared divided by 1 plus T squared. So that will give us 4 T squared all over 1 plus T squared. Yes. Now we have seen the value of our 5 cos square x to be this. Yes, to be this. And we have seen the value of 4 cos square x to be this as well. Yes, to be this. Now let's look at 4 sine square x plus 5 cos square x. Yes, 4 sine square x Yes, 4 sine square x plus 5 cos square x. So 4 sine square x is equal to 40 square. We have 40 square all over 1 plus t square. Then we have plus 5 cos square x. 5 cos square x is 5 all over 1 plus t square. Now the LCM of this 1 plus t square and this 1 plus t square is 1 plus t square. So this into this is 1. 1 times 40 square is 40 square plus this into this is 1. 1 times 5, that will give us 5. So it therefore means that 4 sine square x plus 5 cos square x is equal to 4t square plus 5 divided by 1 plus t squared. Yes. Now let's look at this because this is like saying 1 all over this dx. Yeah, it's the same thing as dx all over 4 sine square x plus 5 cos square x. Now 1 all over this function, 1 all over 4 sine square x plus 5 cos square x will be equal to, we have 1 all over 4t squared plus 5 all over 1 plus t squared. Yes, all over 1 plus t squared. All over 1 plus t squared. Now, it means here we're going to have 1 all over 4 sine square x plus 5 cos square x will be equal to, here we have 1 plus t square all over, yes, all over 4t square, and here we have plus 5. Yes, so now the integral of the whole of this, integral 1 all over 4 sine square x plus 5 cos square x dx will be equal to integral. So here we have 1 plus t square all over 4t squared plus 5. Then now times the value of our dx. I remember here we said the x is the t all over 1 plus t squared. Yes, we have it here. Is the t all over 1 plus t squared. It means this will be the t, yes, the t all over 1 plus t squared. Now this will go with this. Yes, so it means we'll be left with integral 1 all over 4 sine square x plus 5 cos square x will be equal to, we have integral the t all over 4t squared plus 5. Yes, now the whole of this now is the same as saying 1 all over 4. Yes, this 4. Here we have the t all over, this 4 is out. So here we have t squared plus 5 all over 4. Yes, plus 5 all over 4. Now the whole of this now is the same thing as saying 1 all over 4 integral the t all over t squared plus the square root of 5 all over 4 all squared. Yes, and this will give us 1 all over 4 integral the t all over, we have t squared plus the square root of 5 all over, the square root of 4 is 2, so we have square root of 5 all over 2 all squared. So here, now, remember, yes, remember the integral of 1 all over a squared plus x squared. Yes, we have actually done that. Yes, recall. Yes, recall. Recall, integral 1 all over a squared plus x squared, the x, is 1 all over a, then we have tan inverse of x all over a, then here we have plus c. Yes, if you have not actually watched my video on integration of this form, please, you can do. Yes, so now in this case, comparing this with this, now integrating 1 all over 4. Yes, 1 all over 4, or let me call it 1 all over 4 integral the t all over t squared plus the square root of 5 all over 2 all squared. Now this will be equal to, now when you compare this and this, yes, now our x is t, our a is root 5 all over 2. So here we have 1 all over root 5 over 2. Then here, now remember we have 1 over 4 outside. So 1 all over 4 outside. Then here we have 1 all over a. And our a is root 5 all over 2. Yes, then here we have tan inverse of x. Remember, in place of x, we have t. So we have t all over a. And our a is root 5 all over 2. Then here we have plus constant, plus c. It means the whole of this now will give us 1 all over 4. Yes, 1 all over 4. Now this is the same as saying 2 all over root 5. Then here we have tan inverse of t. Yes, so that will be 2t all over root 5. Then here we have plus constant. That's plus c. Yes, plus c. It means the whole of this now will be equal to, now 2 here is 1, 2 here is 2. So we have it as 1 all over 2 root 5. Then we have tan inverse of 2t. Remember we said let t be equal to tan x. Yes, look at it here. Yes, we said let t be equal to tan x. So if t is equal to tan x, so here we have 2 tan x all over root 5. Then here we have plus constant. Yes, so this is the solution to this problem. So thank you so much for listening. Remember to like, share with your friends, and subscribe. God bless you.